In mathematics, the determinant of a square matrix is a scalar value that encapsulates fundamental properties of the matrix, including its invertibility. Specifically, a matrix is said to be invertible if and only if its determinant is non-zero, implying that the associated linear system has a unique solution. Hello everyone, welcome to my channel. My name is Rafael. I am an electrical engineer and bilingual teacher of mathematics and physics from Brazil. And in this video, I would like to invite you for a conversation on determinants. And for this purpose, I selected the 10 exercises. Let's go to the first exercise. Exercise number 1 says, let M be a 3 by 3 matrix such that the determinant of M is equal to 4. The questions, letter A, what is the value of the determinant of 2m? And letter B, what is the value of the determinant of 3m squared? Alright my friends, this is exercise number 1. Let's go to the solution. Let's begin with letter A. To solve this question, it is necessary to remember the properties of determinants. I advise you to remember these properties here. And for letter A, we are going to use that the determinant of k times a is equal to k raised to the power of n times the determinant of a, in which k is a scalar multiplying the matrix and n is the order of the matrix, okay? For letter A, the constant or scalar multiplying the matrix is 2. K is equal to 2. And as the exercise informed us, this is a 3 by 3 matrix. Then n is equal to 3. Okay? Thus, the determinant of 2m is equal to k, which is 2, raised to the power of n, which is 3, times the determinant of the original matrix, 4. And this is equal to 8 times 4, and it is equal to 32. Alright? Consequently, the determinant of 2m is equal to 32. And this is all for letter A. Let's go to letter B now. For letter B, in addition to using this property here, we are going to use this property that says that the determinant of A raised to the power of k is equal to the determinant of A raised to the power of k. Alright? Let's go to letter B. Observe that we can write 3m squared as the square root of 3 times m squared. Can't we? Yes, we can. We can write this in this way, alright? Thus, the determinant of 3m squared is equal to the determinant of the square root of 3 times m squared, and this is equal to the determinant of the square root of 3 times m, and this all squared, okay? Alright? As we saw here, we can write this in this way, and the determinant of this is going to be equal to the determinant of this. And using this property here, the determinant of something, a matrix squared, is equal to the square of the determinant of that matrix, okay? As a consequence, the determinant of the square root of 3 times m is equal to, now k is the square root of 3. For letter A, K, the constant multiplying the matrix was 2. Now the constant multiplying the matrix is the square root of 3. And the order of the matrix is, in this case, 3, because M is a 3 by 3 matrix. Alright, it is easy, just pay attention, times the determinant of M, okay? And the determinant of M is 4, as the exercise informed. Then this is equal to 4 times the square root of 27. 3 cubed is 27. Now we use this property here. The determinant of 3m squared is equal to 4 times the square root of 27 squared, okay? The determinant of this is equal to the determinant of this, which is equal to the determinant of this, which is the question for letter B. Then it is going to be 4 squared is 16, and this squared cancels with the square root times 27, and ultimately find that the determinant of this matrix here is 432. Alright, my friends, and this is all for exercise number 1. Let's go to exercise number 2. Exercise number 2 now. Consider the following matrices A and B. Observe that they are 3 by 3 matrices. And the question, what is the value of the determinant of C if C is equal to A plus B? Okay, my friends, this is the exercise. Let's go to the solution. Firstly, we find matrix C. And as the exercise said, C is equal to A and B. Thus, to find matrix C, we simply add the corresponding elements of A and B. Consequently, C will be equal to 0 plus 1 is 1, 4 plus 2 is 6, 1 plus 3 is 4, 1 plus 0 is 1, 2 plus 4 is 6, 3 plus 1 is 4, 8 plus 9 is 17, 5 plus 8 is 13, and 7 is 10. Now that we know matrix C, we can calculate the determinant. To find the determinant of C, we may use the rule of Sarri. Okay, the way I use the rule of Sarri is this. We simply copy the matrix and copy again these 2 columns. Alright? These are the secondary diagonals. And these are the main diagonals. Alright? In the rule of Sarri, the product of the elements or entries of the secondary diagonals are multiplied by -1. For the main diagonals, it is not. Alright, then it is going to be the determinant of C is equal to -1 times this product here. Okay, follow the arrows. 17 times 6 times 4, okay? 17 times 6 times 4 plus 13 times 4 times 1 plus 10 times 1 times 6. For the entries of the main diagonals, we don't multiply by -1. Then it is going to be positive 1 times 6 times 10 plus 6 times 4 times 17 plus 4 times 1 times 13. Okay? Observe that as the terms are equal, differing only by their sign, the determinant is 0. Okay? We have here 17, 6, 4, but negative, and here 17, 6, 4, positive. We can cancel this with this. Observe also that we have here 13, 4 and 1, 13, 4 and 1. This is negative, and this is positive. They cancel each other out. And lastly, observe here 10, 1 and 6, 10, 1 and 6. This is negative and this is positive. They cancel each other out. Thus, the determinant of C resulting from the sum of A with B is equal to 0, my friends. And this is all for exercise number 2. Let's go to exercise number 3. Exercise number 3 now. What is the sum of the roots of the equation? This determinant equal to 0. Okay, my friends, this is the exercise. Let's go to the solution. To find the roots of this equation, we firstly calculate the determinant using the rule of Sahi. Again, we're going to use the rule of Sahi. We simply copy the matrix and we copy the first two columns and we multiply in accordance with these arrows. For the secondary diagonals, we multiply by -1. And for the main diagonals, we don't multiply by -1, okay? Then the determinant is going to be -1 times this product here. 3 times 4 is 12, times x is 12. X 6 times 1 is 6, times -x is -6x. 7 times 2 is 14, times -1, -14. This for the secondary diagonals. Now for the main diagonals, we don't multiply by -1. 1 times 3 is 3, times 7 is 21. -x with x is -x squared, times 2, -2x squared. And lastly, 4 times 6 is 24, with -1, -24, okay? Developing this, we find that it is equal to negative 2x squared minus 6x plus 11, and this has to be equal to 0 as the exercise imposed that the determinant is equal to 0. Then we make it be equal to 0. And to find the roots of this equation here, we use the quadratic formula. Alright, the quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a, okay? This is the quadratic formula. We're going to use it. Negative b is negative 6, negative 6 is positive 6, plus minus the square root of negative 6 squared minus 4 times a is negative 2, times c is 11, divided by 2 times a, 2 times negative 2, a is negative 2. Developing this, we find that x is equal to 6 plus minus the square root of 124 divided by negative 4, okay? The exercise wants us to find the sum of the roots. We have two roots. Observe here the plus minus sign. We have two roots. Then the sum is going to be, this is the symbol of sum, 6 plus the square root of 124 divided by negative 4 plus 6 minus the square root of 124 divided by negative 4. Okay? One root here is positive and the other here is negative. Observe that they have the same denominator, alright? If they have the same denominator, we can cancel this with this, they cancel each other out. And ultimately, we have that 6 divided by negative 4 plus 6 divided by negative 4. And this is equal to negative 12 divided by 4, which is equal to negative 3. Alright, my friends? So the sum of the roots of this equation is precisely negative 3. Alright, my friends, and this is all for exercise number 3. Let's go to the next. Exercise number 4. What is the value of the determinant of the matrix? This is the matrix, okay? This is the question, my friends. Let's go to the solution. Observe that this is a lower triangular matrix. For all the entries above the main diagonal are 0. This is the main diagonal, and all the entries above the main diagonal are 0. For this case, the determinant is merely the product of the elements of the main diagonal, alright? Thus, the determinant of this matrix is equal to simply 3 times 4 times 2. And this is equal to 24, alright? Very simple exercise just to explore this property that says that when we have a matrix in which all the elements above the main diagonal are 0, the determinant is simply the product of the elements of the main diagonal, alright? And this is all for exercise number 4. Let's go to exercise number 5. Exercise number 5. What is the value of x if the determinant of A is equal to 0 for this matrix here? Okay, my friends, this is the exercise. Let's go to the solution. as the exercise stated, the determinant of A is equal to 0. If it is true, if the determinant of A is equal to 0, we can use a property here that's going to facilitate us find the value of x instead of using the rule of Sahih, for example. We can use the rule of Sahih, but we may use a property that's going to facilitate our calculation. Observe that, let's take this row here, row 3, 4, 8, and x. And let's take row 1, 1, 2, and 3. What if I multiply row 1 by 4? If I multiply row 1 by 4, it is going to be 4. 4 times 2 is 8. 4 times 3 is 12. Okay? Then if x is equal to 12, then indeed the determinant of this matrix is equal to 0. I'm going to tell you why. If the matrix can be converted into, observe that this is possible, scalar multiplication is possible, multiplying an entire row. In this case, this first row, I can multiply an entire row by a scalar, and this doesn't alter the matrix. Then if I can do this, the matrix is going to become 4, 8, and 12, 5, 7, and 9, 4, 8, and x. The matrix becomes this. Okay? I converted this to this by multiplying the first row by 4. Okay? And observe that this row is entirely equal to this row. They are equal. Of course, if x is equal to 12, they will be equal. And there is a property of matrices that enable me do this row 1 minus row 3, and I can substitute in row 1. But if they are equal, the result will be 0, isn't it? If I subtract one by the other. Then, finally, the matrix will be 0, 0, and 0, 5, 7, and 9, 4, 8, and x. And in this case, I substituted this x by 12. And there is a property of determinants that says that whenever there is a row or a column composed of only zeros, the determinant is indeed 0. Thus, if x is equal to 12, this determinant is indeed 0. Alright, my friends? And this is all for exercise number 5. Let's go to the next. Let's go to exercise number 6. Exercise number 6. Calculate the determinant of this matrix here. Okay, my friends, this is exercise number 6. And to calculate the determinant of this 4x4 matrix, we may use Laplace expansion, which says that this is Laplace expansion. The determinant of any matrix of any order is equal to AI1 times the cofactor I1 plus AI2 times the cofactor I2 plus AIN times the cofactor IN. Alright? Or the determinant is equal to A1j times the cofactor 1j plus A2j times the cofactor 2j plus A and J times the cofactor C and J, okay? And what does it mean? It means that Laplace expansion allows the evaluation of the determinant taken as a reference any row or column. We can choose rows or columns. We can choose any rows or any columns of the matrix to calculate the determinant. However, as row 1 has 2 zeros, we will take it as our guide. Observe here that we've got 2 zeros here. We are going to use thus row 1 as our guide, okay? And in this way, the determinant of matrix A will be A11 times C11 plus A12 times C12 plus A13 times C13 plus A14 times C14, in which Cij is equal to -1 raised to the power of I plus j times Mij. And this is the cofactor, and Mij is the determinant of the matrix resulting from the removal of row I and column J from the original matrix. Okay, my friends? And as a consequence, substituting there, the determinant of A will be equal to A11 is 0, 0 times C11 plus A12 is 0, 0 times C12 plus A13 is 1, 1 C13 plus 1 C14, okay? And this is simply C13 plus C14. This is 0, this is 0, this is 1, this is 1, okay? So the determinant of this matrix here can be computed using cofactor C13 and cofactor C14. Alright, my friends? This is how we are going to calculate the determinant. Let me erase here, and we are going to continue this calculation. Cofactor C13. We're going to calculate cofactor C13. Cofactor C13 is equal to -1 raised to the power of 1 plus 3 I plus j times the determinant of the matrix resulting from the removal of row 1 and column 3. We're going to remove row 1 and column 3, okay? So 1, 2, and 3, 2, 1, and 4, 4, 1, and 2, okay? Observe that -1 raised to the fourth is 1. Then this cofactor is simply this determinant here, and we have already learned how to calculate this using the rule of Sahih. Using the rule of Sahih, we find that this determinant is equal to 16. This is equal to 16, okay? You can try yourself in your house and check. This is equal to 16. Cofactor 14 now. C14 is equal to -1 raised to the power of 1 plus 4 times the determinant of the matrix resulting from the removal of the first row and the fourth column of the original matrix. Alright, we remove row 1 and column 4 of the original matrix, and the resulting matrix is 1, 2, and 3, 2, 1, and 4, 3, 2, and 1. Alright? And again, we can find this determinant using the rule of Sahih. If you do this, you're going to find 16. But different from here, it is negative 1 raised to the fourth, which is 1. Here it is different. It is negative 1 raised to the fifth, and this is equal to negative 1. Okay? And this is equal to negative 16. Okay? Consequently, the determinant of the original matrix is equal to C13 plus C14. Alright? C13 is equal to 16, and C14 we just calculated and we found negative 16. And this determinant is equal to 0. Alright, my friends? And this is all for exercise number 6. And this is all for this video. Alright, my friends, this is the video that I wanted to make about determinants. I hope you enjoyed it and learned from it. I am a teacher, guys. If you want to book a lesson with me, use my WhatsApp number. Goodbye!